Hello everybody and welcome to our video today. We are talking about Organic Chemistry Chapter 8, Carboxylic Acids. Woo! Okay, let's get started. So we have just a brief overview. This is a carboxylic acid. It has a carbonyl carbon and a hydroxyl group. The suffix, the suffix is oic acid, and this is the highest priority functional group. So you most likely, will be using this a lot. And if it is a salt suffix, it has the term O8. Sorry, the ending O8. So, a couple important things about carboxylic acids. So first, they have polar and hydrogen bonds, which means they have a higher boiling point, and they are also able to form dimers. Some little fun facts here. Next, we have the alpha proton is most acidic. Again, just another fact that you should know, the alpha proton is the most acidic. Then you can also have something called a dicarboxylic acid, which you see here. It kind of looks cool actually, but it's just, two carboxylic acids, pretty self-explanatory. Now, the carboxylic acids are relatively acidic, so they have a pKa of approximately 4.8. Which means for amino acids, at a neutral pH of 7, this carboxylic acid would be deprotonated. And this is because when if you're comparing the pH and the pKa, whatever one is larger, that would win, metaphorically. So what I'm saying is that pKa represents the molecule. The pH represents the solution. The pH is larger than the pKa, which means the solution wins that proton and the molecule itself will be deprotonated. So that's how I remember those things, but hopefully that helps you, because that took me forever to remember. Okay, so next we have the substituents near the carboxyl group affect the stability of the molecule. So we went over this in the last video, but I'm going to go over it again. So the electron withdrawing groups are more acidic and they're more stable. Electron donating groups are less acidic and less stable. So what that means is the electron withdrawing groups are more stable because they can compensate for that charge. Where we have, if electron donating groups, I like to think of it as electrons just being added. They're trying to juggle all these electrons already. It kind of gets a little more hectic, so it would be less stable. But the electron withdrawing groups kind of help take off some of that load of the molecule. Next, we are going to talk about a couple of reactions. So we have the carboxylic acid synthesis via oxidation. So with that, we're taking a primary alcohol with an oxidizing agent to produce our lovely carboxylic acid. Hopefully you can see. I'll move this a little closer so you can see all of these. Okay. Next we have the carboxylic acid reduction. So this is taking our carboxylic acid and returning it to this state right here. So you need a strong reducing agent. Now this is in brackets, this is just like an intermediate step, but using LiAlH4, that is a strong reducing agent. So that is how you would be able to take a carboxylic acid all the way back to a primary alcohol. So yes, definitely know these reagents that we're using here to do the oxidation and the reduction. Next, we have nucleophilic acyl substitution. So here we have a nucleophile, that is being attracted to this partially positive carbonyl carbon, which is causing this bond, the double bond, to break, which is leading us to have a negative charge on our oxygen. However, that will then need to be reformed, and that is actually going to kick off this Y group right here, and that is how we're going to be left with this. This is just a basic reaction that we see in a lot of chapters, but it also is, covered in this set of reactions as well, so we want to go over it again. Next we have amide synthesis. And I don't know why, but I really like this one. So you have your carboxylic acid and the nitrogen, okay? That has 2 hydrogens in an R group. And so what happens is you're going to create water. Do I have a marker? What happens is you're going to take this, and you're going to produce H2O. So you're going to take the OH from here and the H from there, and you're going to produce H2O. And that is going to give you this amide right here. Yeah, so we saw this in the first chapter of biochemistry as well when we were looking at peptide bonds, and we're using amino acids. So this one is also an important reaction. Draw this one, memorize this one, know this one. All right, I'm gonna move this down a little bit more. Hopefully it stays. All right, so next we have anhydride synthesis. In this case, we're using acetic acid, 2 acetic acids. So we have this acetic acid, which as you can see, is carboxylic acid, right? It has this group right here. And we have another one, right? Our OH carbonyl carboxylic acid. So what happens when we have an anhydride reaction, anhydride synthesis, the anhydride makes you think of water. And so we're going to be producing water. So what happens when these 2 things are put in, I believe it's extreme heat, this is going to combine these 2, and you're going to produce water, and you're going to see this, both of these groups here. And this, in this case, it's producing ethanoic anhydride. Okay? And finally, in this chapter, we have saponification, which is where you take a fatty acid plus a base, and that will give you a salt. Brackets, soap as well. So this is just, a brief example. We have fatty acids, a base, and then this will produce a non-polar tail and a polar head. And that brings us to the end of this chapter. If you have any questions, please put them below. And if not, stay tuned for our next video.